Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 149 of the Observer's Notebook, the official podcast of the Association and Lunar and Planetary Observers. I'm Tim Robertson, the host of the Observer's Notebook and also the coordinator of the training program within the ALPO. Thanks for downloading and listening. The Association of Lunar and Planetary Observers collects and analyzes observations of various solar system bodies and associated phenomenon, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it alive. If you enjoy what you hear on the podcast, you can donate to it via Patreon. You can start by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can find out more by going to www.patreon, that's patreon.com/Observer's Notebook. And if you'd like to join the ALPO, membership begins at only $18 a year. And for you, let you know, membership will increase January 1st, 2023, up to $23 a year. So that's a $5 increase. So if you want to join now, I recommend you head over to www.alpo-astronomy.org. And you can find the ALPO on Facebook. Just search for ALPO Astronomy. And yes, this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode of the Observer's Notebook. Now we're going to talk about Jupiter. It's a month of planets because they're coming into the evening sky. So hope you enjoy it. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And today we have a return visitor, the assistant coordinator of the. Are you still assistant coordinator of the Jupiter section?
I'm coordinator now.
Okay, all right. Richard Schmude, welcome to the podcast, Richard.
Oh, thank you. Thank you, Tim.
Now, before we get talking about Jupiter, why don't you just give everybody a little bit of background about yourself?
Okay, well, I attended public schools in Maryland, California, and near Houston, Texas, and graduated from Texas A&M with bachelor's, master's, and PhD. Got my PhD in 1994, and I've been teaching at Gordon State College since then. And I'm about ready to start my 29th year at Gordon State. So, anyway, it's I've been there a while, and I've been the Jupiter coordinator, either Jupiter assistant or coordinator, since about 2002. So I guess that's about 20 years. Okay. I made my first Jupiter observation through a 40 millimeter refractor from Kmart back in 1978.
Wow.
Late 1978.
Now, how did you get involved with the ALPO?
I read an article. It was either in Sky and Telescope or Astronomy Magazine. I believe the article was about Mars, and I believe Jeff Bish was the author. And he said somewhere, join the ALPO or find out more information. And I joined. It was in the summer of 1981. So okay. I guess I've been an ALPO member for 41 years.
Yeah, I joined in 1972. It's been a long time.
You 50 years. Whoa.
Yeah. I know, it's crazy. Just don't think about that sometimes.
Yeah. Yes.
Yeah. So you're the coordinator of the Jupiter section. Just give me a 50,000 foot view of what the Jupiter section is and what kind of work you do.
Okay. Well, basically we're a group of, something on the order of 50 observers. Most of us take pictures of Jupiter and send them in, although I've got a few to make drawings. And then I carry out brightness measurements of Jupiter using a photometer. And then one other individual, sometimes he records spectra. We've got, and it's those people that are really at the cutting edge recording spectra. I think there was one individual over in Australia who took a polarizing filter, put it in front of a CCD camera, and was able to get polarization measurements. And this is really the future of imaging, I think, is to, let's now, instead of just taking a picture, let's go ahead and get some brightness data of like the belts and zones, or get some polarization data. And of course, that's just one more piece of the puzzle we can use to try to solve, what's exactly going on Jupiter. When a belt fades, what's really happening? When a belt comes back, right, what is really happening? Of course, the more clues you have, the better chances you are to come up with an accurate hypothesis as to what is going on.
That's true. Now, with the Jupiter section, how many, you said you have about 50 active observers. What are some of your most loyal contributors? Who are they? What are their names?
Okay, well, Paul Maxson probably is maybe near the top of the list.
Right.
For a long time, Don Parker was. Unfortunately, he passed away a few years ago. Clyde Foster has been very loyal over the last several years. Let me think who else. There's several. Chris Go over in the Philippines, really, really good.
Right.
He's been very loyal for many, many years.
Yeah, but you're always looking for more observers.
We're always looking for more observers and more ways, more angles to study Jupiter. It's not just taking pictures in visible wavelengths. Taking pictures in methane band light is good. And of course, there are cameras that can go into the mid-IR. Now, it's kind of difficult for amateurs to do it unless they have access to, say, a 1 meter telescope. And some of my observers have that.
Oh, my goodness.
Yes.
Now, with this apparition of Jupiter, it reaches opposition in September. I believe it's September 26th.
It's in September. I don't want to confirm the exact date.
Yeah. I looked it up right before, so I think it's good. What type of equipment? You mentioned, meter telescopes. What kind of equipment, if someone's starting out, would you suggest they have to start submitting observations to the Jupiter section?
Well, actually, you can actually start with something as small as a 4.5 inch reflecting telescope or a 3-inch refractor. And that would be basically sending in intensity estimates of the main belts and zones. And of course, we measure intensity on a scale of, we measure light intensity on a scale of 0 is black and 10 is white. So that's very valuable. Just visible estimates of light intensity are valuable. I compile them and I look for changes from one apparition to next. For example, the equatorial zone has darkened. It started darkening, I believe, in 2018 and has remained dark to at least February 1st of this year. I didn't look at the equatorial zone more recently than that, but that's a little over 3 years. And so we can, that's the lowest. And of course, that would be a good project to start off with. And then as you get to know Jupiter and get into the routine, you can work up to a larger instrument. Of course, remember, the larger the instrument, the heavier it gets. And of course, that can be a factor, especially as you get along in years.
That's true. I think everybody our age has started to downsize their telescope equipment.
Yes.
Yeah. Okay, you mentioned imaging, but what about like drawings? Are those still valuable to the Jupiter section?
I feel they are, and the reason why is we need to have historical continuity. We have basically a series of drawings going back to the 19th century, pretty consistently. We have drawings before that, but they're not consistent, and so we need to have sort of a historical continuity. So yes, I do encourage drawings, either color drawings or drawings done in black and white. One person who has consistently done drawings is Michael Sweatman over in Arizona.
Very good. Now, other than full disk drawings, what other type of observing programs are there within the Jupiter section?
Okay, well, we have transit timings. That was a very big section, say, in the late 20th century. That data can still be valuable. However, we have so many excellent images now. All I have to do is hold up a grid to an image.
Right.
And I can get the longitude and latitude of features. And then we have photoelectric photometry. I'm pretty much a one-man show on that right now, although it would be nice if others can join in. Of course, photoelectric photometry of the Galilean satellites, which unfortunately no one has done, but we can certainly do that. I mean, with CCD cameras, it's not that difficult. And then we have very specialized programs. I think I mentioned two of them, that in one case, recording the spectra of Jupiter, and in another case, getting polarization measurements of Jupiter of individual features. And this is certainly, I feel that this is the wave of the future. And I'm going to make a statement here. There's more potential to get good scientific data today in the spacecraft era than there was in the 1960s.
You're talking from the ground, too.
And from the ground.
Yeah.
Because of the advancement in camera technology. That is the number one thing.
Oh, you look at these photographs that are, I don't know if they're on social media at all, but I look at what amateurs are putting out on Twitter and Facebook and things like that. And I am blown away. I mean, these rival Cassini's photographs of Saturn and Voyager's photographs of Jupiter. I mean, it's just what amateurs are doing with modest equipment.
I mean, Chris Goh and Damian Peach are doing work probably almost, or if not as good as the Hubble Space Telescope.
I completely agree. And these guys are amateur astronomers with modest equipment. I mean, they don't have meter telescopes.
14-inch. I mean, I think that's what Damian has, and Chris may be 11-inch. I don't know.
Right. But it's the skills that they show once they get the image in the processing of the image that's really mind-blowing what they can do with it.
Exactly.
Yeah. Well, Jupiter, like I mentioned, reaches opposition, which is oppositions when the planet rises, when the sun sets. It's directly opposite the sun in the sky.
That's right.
And which puts it as an all-evening object. Now, right now, it rises later in the evening, but it's still easily to see pretty much all night long if you want to see it.
That's right. Yes.
So what are some of the things you're looking for, or what are some of the things you've seen so far in observations you've received of Jupiter?
Okay. One of the big things is the North Equatorial Belt. That's one of the two main stripes, dark stripes you see in the telescope. It is already starting to grow wider since last year. And it will be interesting to see how this belt develops. I just got to look in an image. It's really interesting. When you have north at the top, it's almost like you've got brown waves sticking out. I can just see that belt wanting to reform. And as far as I'm concerned, I believe it is widening as we speak.
Yeah, because it's faded also, hasn't it, over the last few years?
Last August of 21, it was only 2 degrees wide. That's just unbelievably narrow. It's usually around 10 degrees wide. Now, I'm talking about the dark part.
Right. The belt.
The actual dark belt. And it's already increased in width by, 30% or so.
Okay.
And I'm looking forward to increase even more as 2022 progresses.
Yeah, some of the planetary terminology we might use when we talk about belts, they're the darker stripes on Jupiter. And in between that, we have what's called zones.
Yes.
Those are the areas that seem void of anything. But if you look under a lot of magnification, there's a lot going on the zones as well.
Oh, yes. In fact, we had a very famous spot called Clyde Spot developed the middle of last year, and it has since grown. It's changed in darkness too, and it'll be interesting to see what happens to that feature. But it's been around for several months now, and it has grown.
Yeah, and that Clyde spot was actually its discoverer is Clyde Foster, who you mentioned earlier.
Right. That's right.
The observer in South Africa.
That's right. That's right. He's among the best. He is perhaps the most consistent, excellent imager we have right now. Yeah.
In fact, at our recent ALPO conference, he was awarded the Walter Haas Observers Award.
And rightfully so.
And rightfully so, right.
Well deserved.
Yeah. Yeah, long overdue, too, I believe.
I believe so, yes.
Yeah. So what are some other things we're seeing on Jupiter that are interesting?
Okay.
Or that people should look out for when they observe Jupiter this year?
Well, the Great Red Spot is always something to be on the lookout for. I may be wrong on this. It looks like it's gotten just a little bit smaller in 2022 than 2021. Now, of course, I don't have measurements to back that up, but certainly keep an eye on the Great Red Spot, and not just in visible wavelengths. Visible wavelengths are what we just see with our eyes. Look in the methane band images. People are submitting some really good methane band images, and there is some interesting detail in the Great Red Spot, even in methane band images.
Okay.
That's certainly something to keep a watch out for. I believe the Oval BA is another one. That's the second largest oval storm, I believe, on Jupiter. And again, that's always shows some interesting behavior. Recently, it has shown a very thin, dark ring inside of it. It's sort of a darker shade. And I've noticed this for several years. And then before that, it turned orange. Of course, Chris Goh is the one who brought our attention to that.
Right now, are there spacecrafts observing Jupiter right now, or is it pretty much all ground-based?
Juno, I believe Juno's still.
Okay. Juno's still there.
John Rogers over in the United Kingdom has been really good at keeping up with the Jupiter parajoves, and I believe he's sort of a spokesperson for the amateur community to professional astronomers.
Yeah, but total coverage of the planet is really based upon what the amateurs are looking at, because pros really don't spend that much time observing Jupiter, do they?
You're right. A parajove, that's where Juno comes close to Jupiter. It might be once every, I don't know, I'm just picking a number out of my head, 6 weeks or 8 weeks.
Yeah.
And that's obviously not.
So there's a lot of value for amateurs still to be observing Jupiter. So.
Oh, yes. Yeah,
because it's ever changing. That's why I really enjoy lunar and planetary observing, because within a night, Jupiter rotates in 10 hours.
That's right.
So you could see the entire planet pretty much in one evening of observing. If you start, it's amazing that and you can see the movement in 15 minutes.
Oh yeah, easily.
Yeah.
Maybe even less than that if you have a trained eye.
Right. So what are you mentioned like Clyde spot? What are other some significant discoveries or observations that have been made in the past few years?
Okay. Well, last year there was a very interesting loop pattern around the Great Red Spot. It had some very tiny dark spots, and it kind of moved around the Great Red Spot. There has been some I guess I'd call them ovals, but they look like dark rings on the southern edge of the South Equatorial Belt. And what these do is they move along the belt, and then they collide with the Great Red Spot. And this was especially the case in 2020. And of course, we had major flaking events. That's where a portion of the Great Red Spot appeared to just leave the Great Red Spot, become a smaller red fragment, if you will, of the Great Red Spot. And we called those flakes.
Yeah, I've looked at some recent images of Jupiter, and there seems to be a lot of activity surrounding the red spot right now.
Yes, that's right.
What do you think is causing that?
It is, this is just again, a hypothesis, nothing more.
Right.
Is you've got a collision. Basically, you've got these dark, I don't know, cyclone things I call dark rings on the southern edge of the South Equatorial Belt colliding with another large weather system, the Great Red Spot. And of course, when you get a collision, pieces come off.
Mm-hmm.
And so that's what I think is going on.
Okay, that makes sense.
And but I stand corrected. And again, we need more polarization measurements. We need more disk resolved data. This is where you can actually get the brightness of, say, the Great Red Spot, or even a part of the Great Red Spot using a CCD image. You can actually do that. Now, we have the technology to do that, but it is going to take a bit of work to actually do that. But people are capable. They're smart.
Yeah, there's a lot of nice images out there on the internet of Jupiter right now, because it's becoming easier to see in the evening sky. Yes. And I've actually reached out to a few of those observers, like I've seen on Facebook, because this is a beautiful image. What have you done with it? Well, I posted it on Facebook. No, send it to the ALPO. Send it into the ALPO. Let us use it in our research and in our studies. So it's something a lot of these people never even think about. Yes. Well, if you're taking images of Jupiter and you're listening to this podcast and you're not a member of the ALPO, or you don't think your image is good enough, send it in.
Please
trust me. We will take any and all images of Jupiter, because you might be observing at a time that no one else in the world is seeing it, and you might discover something. You never know, like Clyde spot.
That's right, or a new impact flash. In fact, that's another thing I hope people can keep an eye on. It's a hypothesis that I guess Frank Maleo and myself have come up, and that is impacts may be more frequent when Jupiter is close to the sun and closer to the asteroid belts. In the next year, Jupiter is going to be about as close as it can get to the asteroid belt. It'll actually be closest in January of 2023, but even now, it's very close. And so I would expect a higher frequency of impacts than normal for the next year or so.
That sounds like a future article in the journal.
Yes. Actually, it's part of my current Jupiter apparition report that I'm finishing up. So
okay, good.
We'll see it in the ALPO.
I look forward to seeing that in the journal. So is there anything else you want to add about this particular apparition of Jupiter?
I think it's special because for the first time now in a while, Northern Hemisphere observers, particularly our observers up in Canada, are going to get a much better view than you've had in the last 4 or 5 years of Jupiter. It is now, I believe, and since the opposition's in late September, it will have a northerly declination, and that will only improve in the next few years. And so Jupiter's going to rise higher in the sky for people in the United States, or in the continental United States, Canada, and it's in Europe too. And it's just going to get better as we approach the year around 2026.
Fantastic. Yeah, I can't yet get myself out of bed early enough to see it right now. But in the coming months, I'm sure this will be a major target of mine too, as it should be everybody else, because Jupiter is just a remarkable planet to watch.
It's bright. It's the second brightest planet right now behind Venus, and Venus is going to be in conjunction with the sun, so you won't even be able to see it. So Jupiter, very shortly, will be the brightest planet in the sky.
It's true. Yeah. So you mentioned the journal. Is there anywhere else where you publish observations from the section?
For ALPO observations, the journal is the primary section.
Okay.
Now, I am working on a specialized photometry paper, and it talks about several of the planets, including Jupiter, and that is hopefully going to appear in the Georgia Journal of Science. A long time ago, a coworker and I submitted a paper to the Journal of the Royal Astronomical Society of Canada, and I think I did send in another paper to the Georgia Journal of Science. It was basically a summary of the width of the North Equatorial Belt over like 20 or 22 years.
Okay. Interesting. Yeah, and I want to mention to our listeners too, if you find this talk interesting, Richard gave 3 presentations at our recent ALPO conference, and all of those are available on our ALPO YouTube channel as well. He talked about photometric photometry. He talked about Jupiter, and your third one was the remote planets.
Yes, you got it right.
So really, I would suggest you, if you weren't able to attend, those talks are available forever on the YouTube. So just look up our YouTube channel, and you can listen to both days of the conference on the channel. It's pretty cool. We had a lot of interesting talks, but Richard did 3. You went above and beyond, sir.
Thank you. Thank you.
So what do you see for the future of the Jupiter section?
Okay, what I see is we're going to continue getting good images. Hopefully, we're going to continue to see photometry. And what I'm really hoping is that we can join the two together. In other words, when you take a picture of Jupiter, you've got all shades of color. And of course, if you do it monochrome, you're going to get all shades of gray.
Mm-hmm.
And what we need is absolute brightness measurements of like the Great Red Spot or Oval BA or the North Equatorial Belt. In other words, actually get quantitative brightness values of those features. Get a number that can be measured from the image. Okay. We're able to do it with the eyeball, but unfortunately, that's not as accurate as we would like it to be. But that's the future. We're going to we have the potential to have a great deal of new worthwhile studies on how the belts darken, how much they darken. And of course, this will enable us to better predict what's going on and better understand what happens, say, when a belt fades away. And so I see that happening. I think we're going to have more wavelengths of light being used to study Jupiter. In fact, possibly even radio. I mean, that is a possible new ALPO section. It's a radio section. And so I think we're going to have more of a diversified set of data, if that makes sense. I mean, 100 years ago, about the only thing you had were drawings.
Right.
Today, we've got 4 or 5 things, and that's only going to increase. I mean, of course, we've got more wavelengths of light. We've got anything from ultraviolet out to the near infrared now. And of course, I think that's only going to improve. We're actually getting some work done in the thermal infrared, around 10 microns, but that's just the moon. You really need a big telescope to do that for Jupiter, but people are getting access to these 1 and 2 meter telescopes.
Right.
Thanks to computer technology.
So what about the 4 Jovan moons? Is there science to be done with those?
Yes. Photometry is one area that we can do. A second area is Io. Io is an interesting moon because it is volcanically active. Its surface can change. Also, it is warm. I understand its surface temperature is near that of the Earth's, but there's hot spots. And of course, that can be detected in the thermal infrared. And then, of course, for the we've got, I think it was Frederick Pilcher did a paper on Himalaya. That is one of the fainter moons of Jupiter. It's around magnitude 15, but that's well within the range of, say, a 10-inch telescope and CCD camera. That's you can get probably 1% photometry with that on a moonless night.
Interesting. Yeah, I've often wondered that. I mean, is there science to be had from the moons of Jupiter?
Yes,
they're all different. I mean, you look at the 4 Jovan moons, and they are completely different from one another.
But here's the thing, though: to do science, you have to know what people have done. And that includes the spacecraft. The spacecraft have imaged, I believe, all the surfaces of all 4 moons.
Yes.
We already know what they look like in visible light. But, I mean, that's why I mentioned Io. Io can change.
Right. That's
true. The others probably will not change. I might be wrong on that, but they probably won't. But Io for sure can be monitored. And of course, we can do photometry, and of course, even in the near infrared now, we can get. I've got J and H filter photometer now, and I can do photometry in those wavelengths, which a commercial CCD camera cannot even detect that.
Okay. And what is J and H for our listeners?
Those, let's say the J is sensitive to wavelengths of about 1.25 micrometers, and the H filter is sensitive to a wavelength of about 1.65 micrometers. And then, of course, there's even higher wavelengths than that. Professional astronomers are able to do that. Unfortunately, commercially available photometers that can detect in the, say, the 5 micrometer range are not available. Of course, if it's not commercially available, you have to custom build it on your own. Of course, there's some ALPO members I think who can do that.
Yeah,
but it's going to have to be a labor of love. But I can see people getting measurements even at 10 microns in the thermal infrared. But you're just going to need a big telescope, or you're going to need a way to get the brightness measurement, get a quantitative number. And it can be done. It can be done. Our atmosphere is actually transparent to wavelengths of around 8 to 11 micrometers.
Okay. Wow. This is interesting, Richard. Now, is there anything else you want to share about the Jupiter section or this coming apparition?
All I can say is this is a great time to observe Jupiter because it's going to be at opposition in September. We know the temperatures are not too hot, or not too cold in September. So I think this is a wonderful opportunity. Get on out. September, look for Jupiter in the east shortly after sunset. And, sit out, observe it, enjoy it. It'll be a great object for the fall skies in September, October, and even into November. So I think this is a really great opposition. I'm looking forward to it.
Yeah, me too. Well, Richard, I really want to thank you for coming on the podcast today.
Oh, you're welcome.
All right, this is good. Thanks a lot.
Okay, you have a good day.
All right. Well, I want to thank Richard Schmude for coming on today to talk about Jupiter and the upcoming apparition. I want you to get out there and observe Jupiter. It's going to look pretty awesome this year. We upload new episodes of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please rate us and review us. I really would appreciate it. It brings more people onto the podcast. You can also listen to us on Apple Radio, iHeartRadio, SoundCloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and also we are available on our YouTube channel as well. You can help support the podcast by donating to it via Patreon. You can give up to $35 a month, where you will receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I want to thank the producers of this podcast, Steve Siedentop and Michael Moyer, for their continued generous support of the Observer's Notebook. Thank you very much, gentlemen. The link for the Patreon, as well as the link for the ALPO, is in the show notes. If you'd like to get a hold of me, my email address is commentman@commentman.net or on Twitter at ObserversNBpod. Until next time, my hope is have clear and steady skies. Thanks for listening.